Okay, well, why don't we get going for today? Not very long today, just briefly, I wanted to show you guys how to get into the packet tracer and get started with these two labs. Unfortunately, there's a little gotcha in one of the labs in that packet tracer just is not able to handle the secure shell stuff. Can't do HTTPS, can't do secure shell. So if we were in the real room with the real equipment, that would be no problem. We could do it on the real stuff. It would work great. So as a workaround today, after I show you how to just to drag and get started in these two labs, get the connections going, and then you can do the step-by-step in the labs. I'm going to go into another simulation program that'll show you how secure shell works. Okay, let's see now. I need to pull up this screen just to show you the assigned lab printouts for today. And it's these two, 5116 and 5229 is the ones that you've assigned for today. I've assigned to you for today. Okay, I can stop sharing that. And I want to share the picture of the first lab. Okay, this first lab, 5116, I think it was, 5116 is the lab where you're going to do some basic configuration of the switch switch, just basic settings, set up a VLAN address, and see if you can ping from the workstation to the switch itself. And the other lab is more complicated, slightly more complicated, not too bad. So in this lab, we're going to add a router to the topology. You will be able to do part one, step up the topology. You will be able to configure basic device settings and verify connectivity. Part three is the gotcha. We'll have to skip that part on the packet tracer because the ability to go into packet tracer and do this modulus key thing with 1024 bits isn't implemented on packet tracer. You can't do it. I'm going to show it to you on another program. Okay, so let's see. I'm going to go ahead and stop this and share my packet tracer. And let me drag it around here so it's as big as it can possibly get. There we go. Okay, on this first lab, there's a S1 switch and a PCA connected together. So I'm going to go to packet tracer down to the where it shows the routers and the switches. I'll go over and click on the switch icon, and then I'll take a simple 2960 switch and drag it into the topology, and I will change that from its default hostname of switch. Oh, okay, it's still booting. All right. Okay, it's booting now. And I'll call it switch one. Now it shows up as switch one, and if we go into the iOS, I already renamed the hostname to S1. Now we need a PCA. So I'm going to go down to change it from routers and switches and network devices to end devices, intermediate systems, end systems. I need an end system, or as Cisco likes to call them today, endpoints. So I'll just choose a standard PC and drop it in the topology. And the host name in this lab is PC-A. So I'll go ahead and just to avoid confusion, go and change it to PC-A so it looks right. The connection between these two is, now in the lab they show the solid black line as the Ethernet connection. I'll go ahead and make that connection. Choose a solid black Ethernet and go from the standard, the single Ethernet port that's existing on most PCs, and then I'll click on the switch and it's port number 6, which is kind of off the top of your screen. Now in the lab they also show the little line that goes in an arc shape, rainbow shape from PC-A to S1, and that's the console connection. Now you can do that in Packet Tracer. You can add a console connection, but it's easier, I think, just to simply click on the switch, bring the console into the shape, go to the CLI, the console connection, and you can go in your type your code and do that. And then you can go ahead and proceed with this lab, add IP addresses to the PC, create the addresses and do the configuration on the basic switch itself. Okay, now I'm going to go to the second lab, and let me see, I'm going to have to go into Packet Tracer and tell him to forget this lab, and he's going to say, oh, you haven't saved it yet. Okay, I'm going to stop. No, I don't have to stop. I have to pull this down so I can see it. Okay, in the second lab, there's 3 devices. There's a PC-A, there's an S1, and there's an R1 router. So I'm going to put the router in first. I'll go to Network Devices, Visible, good. I'll take the 1941 router, which is the one like we actually have in our room, and go ahead and give them the proper host name and appearance. It's still booting. It boots up a lot faster in Packet Tracer than real devices. Real devices take about 3 minutes to boot up. So this guy will be enabled, called R1, and I'll make it the actual R1. It'll configure that for you, so you don't have to do that. Okay, the next item in the topology is a switch. So like I did before, I'll click on the switch and pull the switch in the configuration and give them a meaningful host name. Wait till it boots up. So he's going to be switch 1 on the diagram, and actually S1. Now S. So that's fixed now. And then we'll put a PC in there. We'll click in devices, put the PC in the topology, and again, he's called PC-A. So I'll go to the configuration and type config PC-A, so it looks right. Now here's the gotcha. I wanted to illustrate this gotcha. Oh, let me connect them together, and then I'll show you what the problem was in the switch. And even in the router, it doesn't work either. I tried doing the router SSH, and it doesn't work either in Packet Tracer. So I'm going to click on the jagged lightning bolt thing, and the router is connected. Oops. Choose a line. There we go. So the router is connected from G00 to the switch's F5 port. And then the switch's F6 port goes to the NIC card in the PC. So that takes care of those connections. Now here's the problem. I'm going to go into the switch and bring up the CLI here and put it on the screen. We can see it okay. Okay. See, you can't see my mouse moving in there because of the Blackboard Collaborate doesn't show the mouse in this one. It shows the mouse in most stuff, but not this. So here's the problem. I'm going to step over to the lab here on my screen, over to the code. We're doing the SSH stuff, and some of it starts to work. He tells you to go into the switch and type the IP domain. Oops. Domain name CCNA-RSE.com. Exact command. The next command, he says, type the command username. I'm going to use Cisco in class instead of admin. Cisco. privilege level 15, which is equivalent to the privilege exec mode, and the secret password, I'll just use class, Cisco and class, like we normally do. It takes that command fine. And then in the next page of the lab, he tells us to type line BTY 0 through 15. That works fine. Transport input SSH, which is the line of code that says only accept secure shell, don't accept unencrypted telnet, for example. So the difference is telnet doesn't encrypt anything. Anybody could run a copy of Wireshark and see your activity over the network, including your name and password and everything that you're seeing. So secure shell is a protocol that encrypts everything, uses some secret keys. That's the problem with packet tracer, is this next step we're supposed to do. Log in local, which means use the username of Cisco and the password of class we created earlier. And then the problem is, I'll type the word exit. That next step, step D, generate a crypto key. So if I type crypto key generate RSA, all that's fine, but you're supposed to type the word modulus. It doesn't have it there. So we can't put in the command that tells it to use a 1024-bit modulus key, and it's not going to work for us. Okay, so here's my workaround for this. I'm going to simply demonstrate. You guys will not be. You guys are relieved of the awesome duty and obligation of having to do this particular step in the lab, because packet tracer just won't do it. Okay, so what I'm going to do is bring up another program that actually will work on, and show you what it should look like when the ability to do SSH. So I'm going to stop sharing this, and I'm going to bring up another program which I don't think I've ever shown this to you guys before. It's called the GNS. Let me bring this up on the screen. Is it being shared? Oh, good, it's being shared. Okay, a couple of words of explanation. Packet tracer doesn't actually run the real iOS code. It's a sort of like a macro media flash simulation of what routers should look like when you go to the command line. It's a pretty good program in that it has probably 90% of the features that you need to study for your CCNA certification, but it lacks a couple of weird things. Now, when we were in the classroom, we used the VMware program, and we used VMware to boot and run real versions of Windows 10 that you were the administrator on. You could set the network addresses on them, and you could connect the PCA to PCC and ping and so forth. So GNS3, it's a free program. GNS3 is a program that allows you to boot and run the real iOS. So it's kind of like a VMware for Cisco. There are several programs out there that do that. This one's fairly simple and easy to use. There's a gray area, however. How do you get a hold of the real Cisco iOS code? Since we're a Network Academy, we can get the code. If you don't have access to a Networking Academy, well, if you do a search for the iOS image files on the internet, you'll probably find them in websites that are in, the Ukraine or Russia or North Korea or something like that. And then you got to worry that, is it got a virus in it, or is it the wrong checksum or something like that? So the GNS program itself is totally free. It was actually written by a Cisco guy in France, and Cisco has been very supportive of this stuff. But their attitude is you're on your own to get the iOS. We're not going to make the iOS available for you to download if you're not a legitimate Cisco customer. So Cisco maintains a website where their actual customers that buy their real equipment, well, they can download updates. They can get the files if their router flash drive goes bad and they need to get a replacement copy of the Cisco iOS. They can get it. So the particular iOS that works real well with this is widely available on the internet. And if any of you guys decide you want to download the GNS program, my position is, since we're authorized Cisco Networking Academy, I can give that to you. So if you want to install the GNS program and do some more advanced stuff, particularly in the last two courses, you can do that. So what I've done here is I have created, the mouse is working, oh good. Oh, sorry, the mouse is working, okay. I'm going to use R1 as a SSH server, and I'm going to use R2 to be a sort of a fake host machine. I'm going to turn off all the IP routing in it and just have it try to log into the R1 being the SSH server. So I've already started these machines. They're connected to each other to the F00 ports. And let me see if I can unminimize R1 here. And let's see if I can share it and show you how that works, because it's a separate, it's kind of like when you run Packet Tracer, it pops up that separate screen. So I'm going to stop sharing this and see if he allows me to share that. Here we go. Okay, so are we in R1? Oh, I got to click it on the real screen. Oh, good, my cursor on my mouse is working. Okay. So this is just, it's just been given a host name. If I type show IP interface brief, you can see this is a standard looking router, like our kind of like our 1841s. It has 2 Ethernet ports, has 2 serial ports. Nothing has been yet configured. So what I'm going to do is configure connectivity between R1 and R2. I'm going to call R2 the fake host machine. Just prove IP connectivity works, and then we'll see if we can get this SSH working. So I'll go to the global configuration mode. I'll go to the interface fast. Sorry, not range. Fast Ethernet 0/0, because I connected the 2 0 zeros together. And let's give them a real simple IP address. How about 1.1.1.1 with a /24? And then I'll perform the no shutdown command. Oops, I hit the caps lock key. But it takes it, it's not case sensitive in this case, insensitive. And here's our Cisco unknowns that popped up on the screen. Now I'm going to go to the other. Stop sharing this. See if we can share the R2 screen. Okay, I did a couple of things already to this. I changed the host name from R2 to fake host because I just want it to be like a PC. I'm simply going to use it as a, I turned off the routing function with no IP routing. I just want it to be like a host machine would be. So the host name is fake host, no IP routing is enabled. And we're going to configure this now with an IP address and make sure we can ping back and forth to R1. And then I'll see if I can get the SSH working on the R1, the real host, the real server. And then go to this machine, which we're pretending is going to be a PC, and see if the PC can log into the server over the connection. Okay, so how about if I go, I'm in the configuration mode, how about interface, fast Ethernet 0/0. And let's give them an IP address, how about 1.1.1.11. And do a no shutdown command. So now when we type show IP interface brief, you see it's 1.1.1.11. And should we be able to connect to the other device? If I do show CDP neighbors, it hasn't been long enough. I haven't done shutdown long enough. Theoretically, I should be able to see the R1 host. But let's ping it. Ping 1.1.1.1. I do no shutdown? Yeah, I did. Okay, it pings, it pings. So we have IP connectivity between the 2 machines. So if I did the normal line VTY04 password Cisco, I would be able to tell that to this device, but that would not be encrypted, and that was the danger. Is someone could run Wireshark who had no business looking in there and be able to mess with that. Okay, so what I'm going to do now is flip back to the first machine. Let's see, unshare. Let's share R1 again, because I'm going to type the code in on R1 that you would have if you had a real machine in the lab, a real switch. You would have typed that to the real switch. Oh, stop this. Wait a minute, where'd my R1 go? Hang loose, I just blew it up here. R1. Okay. Okay, here's R1. Now, in that page in the lab where it talks about Part 3, configuring and verifying SSH access on S1, well, this is going to be R1. Most of the code that you can type in the iOS for routers and switches is pretty much the same. If you learn it on one, you learn it on the other. So on that screen in the lab of Part 3, he tells us to go into the global configuration mode, configure terminal. Then type the IP domain name. Oh no, I typed the C instead of a D. IP domain name, and he says use CCNA-lab.com. When we do labs, it doesn't matter what domain name you make up. You can make up any name you want to because you're not on the real internet. Now, if your device was connected to the real internet in your company, you would probably use the actual authorized host name that your company was using. So for example, if this was a Tarrant County College machine on the real network, we'd probably call it tccd.edu or something like that, since we're actually on the real internet on our real machines. Okay, I'm gonna type in a username, and I'm not gonna use admin. I'm gonna use Cisco in class just because it's easier to type and I can remember it easily. So I'll username Cisco, privilege level 15, which is the privilege normal, privilege level, privilege user mode, enable mode, and then secret, I'll say class instead of SSH admin like he says in the class. Arbitrary username and password. Then we normally would say line VTY 0 through 15 through a switch, or 0 through 4 for an iOS, and then transport input. On our routers in the lab, the default is transport input none. Do not allow any kind of connectivity by default from the outside world. So you would at least have to say transport input telnet. Or in this case, we're going to say transport input SSH because we just want to allow secure shell input. We don't want to allow any unencrypted input. And normally we'd say login password Cisco. I want it to log in using that username Cisco in class that I made up. So I'm going to say login local. Back there. Now here's a step that failed in packet tracing. Let's see if it works here. It should be okay in this one because this is the real IOS. Secure shell requires a key exchange procedure so that both machines have the ability to, using the 1000-bit key, encrypt their data. And since you're an unauthorized user and you don't have the key, you're not going to be able to see the information. So I'm going to type the command crypto key generate RSA, and modulus is the command that would not work. It was not implemented in Packet Tracer. So I can complete the step now. So it's going to do generate a 1024-bit key, and it's stored on this machine. And now, in theory, I should be able to go back to my fake host machine and connect to this machine. Oh yeah, I had one more thing here. It says show SSH. Let's just do that, just to see how it lines up with our lab. Show SSH. So he tells me we can run secure shell version 1 or 2 and show IP SSH. We're running version 1.99. Nobody's connected right now. I have not connected from the other host. Okay, so if I stop sharing this now, and go back and start resharing R2, which is going to be our fake host. Let's see if we can get the connection going. Okay, here I am at fake host. Can we still ping him? Did I blow it up yet? 1.1.1.1 is our R1 is now running SSH server. I want to be an SSH client and log into it. So it's just similar to being at the command line prompt from Windows. You can do this from Windows as well. I'm going to type SSH, and I wonder what the next command is. Oh, yeah, I guess I should tell him what my name is. Wasn't it Cisco? And then what else should I do? I should just be able to type his IP address, 1.1.1.1. Okay, what was my password? Oh, it was class, wasn't it? Not shown on the screen. And I am logged into R1. So show SSH. That little delay here, I'm logged in. And look, I'm running. I'm connected. I'm at port number 1. I'm running. I'm session has started with me. I'm connected to it. shell IP SSH was the command that just said we're running that particular version. So it works okay if you have a real iOS running on real machines, or in the case of GNS3, like a VMware simulation, you're running the exact code. When you guys run Windows 10 on your VMware, when you're in the Real Computer Lab at South Campus, you're actually running the exact same code that Windows 10 would run if it was on a real hardware device. It's just being virtualized. There's a couple of alternatives for some free, some that cost money for being able to do, if you want to get the absolutely pure iOS. GNS3 is totally free. I will be happy to send you the iOS code that works the best with it if you want that. Just pop me an email and I'll create a link or something where you can download it or you can get it emailed to you. There was another program called EVE-NG, that's spelled EVE-NG. The GNS program has been out for many years. It only works with the older routers, version 12. iOS version routers and earlier. Doesn't have any really good iOS version 15 and above. So that's several years out of date, but it's perfectly good for studying for your CCNA. So EVE-NG is a program that will allow you to run some more current versions of the iOS. That we're getting, again, into a gray area if you're not an authorized Cisco reseller or a client where you've actually bought later products. Technically, you might be in some state of copyright restriction or violation to be able to download these files. If you're a Networking Academy, you can probably get that. So I have actually configured EVE-NG, which runs as a virtual machine. You have to get VMware Player, which is a free product for VMware. And it has some of the later iOSs that are in there. Now, Cisco has had a product for many years called Viral, V-I-R-L, which is like, it's like all these other things on steroids. It's an authorized product from Cisco. You get all the latest codes for all the latest routers and firewalls, and you can even have a Linux server and workstations in there running all that stuff. But it's not free. It's $200 a year subscription. Now, what some people do that use GNS and EVE-NG do is they pay for the subscription for 1 year just so they can get the ability to download. There's like 7 gigabytes of iOS files that you get when you download this program, when you get this Viral program from Cisco and pay for it. And then they don't renew their subscription, and they use the one downside with the Cisco Viral is it only allows about 20 devices. Well, that's great for CCNA, CCNP stuff. You're never going to need more than 20 devices. If you're a CCIE type candidate, you're looking for a very, very complex topology, you still would have to use GNS3 or EVE-NG to do this stuff. Don't buy Cisco Viral quite yet. It's at a version 1.6. Later this month, they've announced, and they should start shipping Viral version 2.0. And the earlier versions of Viral were very difficult to install and configure. They fixed it up now where it's pretty much packet tracer-like simplicity. You can install the Viral program very easily, get it up and running, and very easily click in and create your topology and do your labs. Version 2.0 of Viral will be shipping soon. Go to virl.cisco.com and watch for that 2.0 version to be announced. And if you want to get this product, $200 product, I think I'm going to get it just to get a look at it and maybe be able to demonstrate it in classes here to be able to do that type of stuff. Okay, I'll stop sharing this. Here's my notepad file. Okay, so we looked at the basic getting started with the 2 packet tracers in these labs. We talked about the problem that you can't do secure shell and packet tracer. You also cannot do HTTPS, which is the port 443 encrypted web version. You can start a basic web server on a Cisco device with IP HTTP server, but if you try to type the command IP HTTP secure server, it doesn't work. It's not implemented in packet tracer. So a few of the labs in the advanced courses use that, so we have to skip those. So I demonstrated using the secure shell feature in a GNS3 program, and you guys don't. I just wanted to show you how SSH works. It's encrypted back and forth, so everything's safe. You can't see it with Packet Tracer. Or you can't see it with Wireshark, which is our packet sniffing software. Okay, so coming up Wednesday, we will have a PowerPoint slide deck on VLANs. And just to briefly, an introduction, VLANs are, when you think about a switch, an Ethernet switch, it's all one big broadcast domain. If a broadcast frame flows into a switch port, it's compelled to be flooded out all the other ports on that. So on a 24-port switch, if I shoot a broadcast into one port, it's going to be broadcasted, replicated out all those other 23 ports. So for small businesses, that's okay. You just need one broadcast domain, one IP subnet. But some companies want to, for security purposes or to reduce the size of broadcast problems in their entire network, they like to divide the company up by department. So, for example, if you had the marketing department and the advertising department, and the marketing department people didn't want anybody to try to see the secret marketing plan that they're going to have for 2021, you can use VLANs to sort of create two broadcast domains on a switch, and maybe pick ports 1 through 12 be one broadcast domain, and there'll be 192.168.10. something, and maybe use the other 12 ports to be the other department's broadcast domain, and there'll be 192.168.20. something. So when we look at the VLAN stuff next time, we'll talk about how to chop the switch up into separate broadcast domains, and you won't be able to ping from a PC that's attached to VLAN 10. He'll be able to ping other guys in VLAN 10, but he won't be able to ping anybody in VLAN 20. A little bit later, we'll look at how to solve that problem. We'll put a router in, because routers connect networks together, and we'll look at the subject of inter-VLAN routing. But Wednesday, we're just going to look at basic VLANs and how they work. Okay, let's see. Hold on a second. Let me check before I cut you guys loose. We got a couple people that logged in. I need to get them in the roles here, because it's all about who came to class and who do we get the money from Austin from. Okay, I think I got everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, you, him. Okay, guys, again, as a reminder, I have to lock the classroom, the generic classroom, during this class so that people don't actually go into it and they hear nothingness. So after I disconnect from this session, I'll open up the classroom again. Microphones are enabled in the classroom. You guys can go into the classroom anytime, 24 hours a day, except during this class lecture period, and be able to talk to each other and do stuff like that. And then I just blank it out here shortly before this class starts, so no one is able to get in there and do anything. Okay, so please work on these two labs. Some of you guys have already finished them. A lot of you guys are, a few of you guys are already caught up. Please work on these two labs and get caught up for this. We're pretty much caught up in our schedule since they stole a week from us at the beginning of the semester. Look for a letter in your TCC student email system about some announcements from the Dean of Students, the Vice President, about they have extended the drop date and they're making some technology available. I think you guys are already, you're here, you have the technology, you're here now. So they're going to send a general letter to all students in case they're having a technology problem, just like they're doing with the public school students. They're giving out Chromebooks to them. The board of directors bought about 4,000 Chromebooks, and they're going to be distributing those to students that need them. So that's going to be made available for students. There's also the $750 grant is available if you can demonstrate financial need. A lot of you guys have been laid off, have problems. That's not a loan, that's a grant that doesn't have to be paid back. And I sent everybody email out, and it's in the announcement section of my TCC Blackboard. There's a PDF file that announces how to, if you want to try to get that, that's how you do that. Okay, I'm going to mute my microphone and say thank you guys for coming. I'm glad you guys are all here, and I look forward to meeting you again next time. And this is Mark now going on mute and going